Hello. Hi, everyone. I'm Dr. Pratibha from the team MDS Conqua. In this presentation, I would like to discuss about the topic endodontic instruments. Though many instruments used in general dentistry are used in endodontics also, there are special unique instruments are designed for the endodontic purpose, about which I'll be discussing in detail in this presentation. So, before getting into the details, um, few points to be noted are the first endodontic file. It was made by Edward Maynard, and standardization of instruments given by Ingle and Levin in the year 1959. And it was in the year 1989 American National Standards Institute. It gave the ADA specification number of 28 for endodontic instruments. Just make a note of all these points that can be asked as an MCQ. So let's move forward. Coming to the classification of endodontic instruments. According to the use, this classification has been adapted from the book Grossman. According to the use, they have been categorized as Group 1, Group 2, Group 3, and Group 4. Group 1 being the hand instruments that include smooth broaches, reamers, and files. And Group 2 that includes the engine-driven instruments with the latch type of attachments, such as Gates Glidden drills and piezo reamers. And Group 3, these are the instruments which are engine driven. That includes rotary NITA instruments, reciprocating instruments, and self-adjusting file. And the group 4 of this classification includes ultrasonic and sonic instruments. Moving forward, one more classification is important, which is according to ISO and FDI. It also classified instruments into 4 groups. Group 1 includes the instruments for hand use only, that includes files, reamers, broaches, pluggers, spreaders, etc. And Group 2 are the instruments which has the same design that has of Group 1, but these are engine-driven latch type. Examples are lentillo spirals. And Group 3, these are the engine-driven latch type drills or reamers. Examples include Gates Glidden drills and piezo reamers. And the Group 4 includes the endodontic points such as gutta percha points, silver points, and absorbent paper points. And this is the most important aspect in the endodontic instrument, from where even numericals can be asked in your entrance examination. So why standardization of instruments was proposed? During one point of time in history, manufacturers, they prepared instruments according to their own will. Um, there were instruments were arbitrarily numbered from 0 to 6 in number, and also instruments of one manufacturing company doesn't coincide with the instruments of other manufacturing company due to difference in dimensions of the instrument, such as length, diameter, or whatever. So to prevent all these drawbacks, Ingle and Levin, they proposed the standardization of the endodontic instruments. So let's go into the details of the recommendations from the standardization of endodontic instruments. The first one is instruments are available in the lengths of short 21 mm, standard 25 mm, and long 31 mm. 21 and 25 are normally used for the regular purposes. 21 mostly used for the molars and also in patients who has limited mouth opening. And 31 mm or the long files, sorry, 31 mm or the long files, these are used for cuspids or for long teeth, where 25 mm files cannot reach the apical foramen. And the second recommendation in the standardization is all the instruments are numbered from 10 to 100. Like just in case, see 10, 15, 20, and 25, so on till 60 number. Then 70, 80, so on till 100. So if you see, it clearly shows that till the 60 number of the endodontic instruments, there is an advancement of 5 unit size between the successive files. But after the 60 number, there is an advancement of 10 units in size till the 100 number. So in the original recommendation, the numbering was from 10 to 100 only. But later it was revised to include the smaller number of file sizes such as 6 and 8, and also larger number of file sizes till 150. That means more than 100 till the 150 number have been included. And next, third important point is that each number of the instrument, instrument, it should represent the diameter of the instrument at the tip, means at the D0 in hundredth of millimeters. So to simplify it, let's take an example of 10 number file. So for as this file has the number of 10, the tip diameter of this file, it should be represented in hundredth of millimeters. That can be written as 10 by 100. That gives of 0.10 mm. I hope you're clear. If there is any confusion, let's take another example. So if we take another example of 45 number file. So this number represents hundredth of millimeters of diameter at the tip. That can be written as 45 by 100. So that gives of 0.45 mm at the tip. So tip diameter can be taken as 0.45. And this is the third important recommendation from the standardization. So coming to the next important point, the cutting surface of the instrument. It is 16 mm in length, starting at the point designated as D0, and it extends shaft till the point D16. So the total cutting surface of the instrument will be 16 mm in length, with the initial point as D0 and the end point as D16. And about the diameter D0 we have already discussed, and the next important specification is the diameter of D16. This diameter at the D16, it should be uniformly 0.32 mm greater than that of D0. Again, just to simplify it, one more example. If we take a file number of 15 number, if we take a file number of 15, it has got the D0 of 0.15 mm. So if we want to calculate the diameter at the D16, it can, so usually D16, it should be 0.32 mm greater than that of D0. That means for the 15 number file, if you want to calculate D16, it can be taken as 0.15 plus 0.32, which mounts up to 0.47. I hope you are clear with this concept. The diameter or D16, it should be always 0.32 mm greater than that of D0. And this ensures the constant increase in taper from the tip to the shaft of the instrument. So these are all the original recommendations. Later, there were few modifications which has been added. What are those modifications? Let's see. Um, Previously, the tip it was designated as D0. Later, it has been changed to D1, and D16, which was earlier designated, it has been changed to D2, and additionally, one more measurement was given in the modified specification, modified recommendation, that is D3, which is 3 from the tip. And also, one more modification is that when the original recommendation was proposed, there were only 2% taper instruments were available. That ensures a 0.2 increase in diameter from the tip to the shaft of the instrument. But later, greater taper instruments were also made available. That includes 4%, 6%, 8%, and even 10%. And one more important point is about tip angle present at the tip. The tip angle, it's the specification is that the tip angle is 75 plus or minus 15 degrees. And most important added specification is about color coding. This is for the easier recognition of the instruments. 6 number, as we have already told, as we have already discussed, instruments were numbered from 6 to 150. Sorry, here till only 140 is there. Instruments are numbered from 6 to 150. In that, the 6 number files are color coded as only pink, 8 number being color coded as gray, and 10 number color coded as purple. And later on, the color codings are white, yellow, red, blue, green, and black. And this color coding, except the pink, gray, and purple, has been repeated for every six set of instruments. As we can see here, from 15 to 40, this color coding has been done, and later again it's been repeated for 45 to 80, and the same has been repeated for 90 to 140. So except 6, 8, 10, the rest of the colors from white to black will be repeated for every 6 set of instruments. Just memorize this table. So coming to the design of the endodontic instruments, and the basic components of endodontic instruments are taper, core, flute, cutting edge, land, helix angle, pitch, and the rake angle. And let's know about these components in detail now. The first component of endodontic instruments is the taper. What is taper? Taper, it is expressed as per increase in diameter from the tip towards the file handle. Earlier, we have already discussed, earlier 2% taper instruments were available, and later greater tapered instruments have been developed with 4%, 6%, 8%, and even 10%, which help us in preparing canals of wider diameter without over enlarging the apical foramen. So here, let's take an example of 30-number file. For 30-number file, whatever taper it is, whether 2% taper or 4% taper or 6% taper, the apical tip diameter, it would remain same, that is 0.30. But the successive diameters depends on the taper of the instrument. If the instrument is of 2% taper, then the successive diameters will be, for number 30 file, successive diameters will be 0.32 from 1 from the tip, and 0.34 at 2 from the tip, and 0.36 at 3 from the tip. In the same way, if the instrument is of 4% taper, At apex, we have already discussed that apex diameter would remain the same for any taper, and the successive diameter at 1 mm from the tip would be 0.34, and at 2 mm from the tip will be 0.38, and 3 mm from the tip will be 0.42, ensuring that there is an increase in 0.04 mm for every millimeter. And if the instrument is of 6% taper, here also same thing is applicable. The apical diameter is of 0.30, and the successive diameters um, will be of this, ensuring that there is an increase in 0.06 mm increase in diameter for every millimeter. I hope you're clear about it. And moving forward, next component of the endodontic instrument is the core, which is the cylindrical center part of the file that is bordered by depth of the flutes. And next component of the instrument is the cutting edge. This cutting edge is the cutting part of the file, also referred as blade. This blade is present between the flutes, and it follows the grooves or flutes when it is rotated. And next component of the endodontic instrument is the flute. Flute, as you can see here, these are the cutting edges, and the part between the cutting edges here, this groove is called flute. This flute, what is the function of the flute? Flute helps in collecting soft tissue and dentin chips that are removed from the walls of the canal during the instrumentation. And moving forward, next component of the file is the land or radial land or marginal width. Um, if we take the cross section of the file, um, radial land is the surface that projects actually from the central axis towards the cutting edge between the flutes. This is the flute or groove area, and this is the cutting edge. So our radial land is the surface that projects from the central axis towards the cutting edge between the flutes. So the main function of radial land is that it supports the cutting edge or blade, and also it prevents the screwing in effect of the file and maintains the file in the center of the canal. And next component of the file is the helix angle. So what is helix angle? Helix angle is the angle formed by the cutting edge. Here we can see the cutting edge or blade, cutting edge with the long axis of the instrument. This is the long axis of the instrument. So the angle formed by the cutting edge with the long axis of the instrument is the helix angle. So what is the function of the helix angle? This helix angle helps in removing debris that is collected in the flute from the canal during instrumentation. And next component is pitch. Pitch can be described as the distance between the corresponding points on the cutting edge of the instrument. And next important component of the endodontic instrument is the rake angle, where we get confused a lot. So let's look at this picture first. This picture shows the cross section, that means horizontal section of a file. When a file is horizontally sectioned, that will have a radius of that cross section. So rake angle is the angle formed by the radius of the cross section of the file with the leading edge or cutting edge or blade of the endodontic instrument. I repeat again, rake angle is the angle formed between the radius of the cross section of the file with the leading edge of the endodontic instrument or file. So this rake angle can be negative rake angle, neutral rake angle, or positive rake angle. Just see here, if The angle formed by the long axis of the leading edge with the radius of cross section of the file, if it is obtuse, that means greater than 90 degrees. If it is obtuse, that means greater than 90 degrees, then the rake angle is considered to be positive. And if the angle formed between the long axis of the leading edge and the radius of the cross section of the file, if it is acute, that means less than 90 degrees, then it is considered to be negative rake angle. I repeat again, if the angle formed between the leading edge and the radius of cross section of the file, if it is obtuse, then it is positive. If the angle between the leading edge and the radius of cross section of file, if it is acute, then it is negative. So positive rake angle, it helps in cutting motion of the file, whereas negative rake angle, it helps in scraping motion of the file. And next, let's get into details of the hand operated instruments. The first one is barbed broaches with the specification number, ADS specification number of 63. These were the earlier endodontic instruments primarily used for extirpation of the pulp. And we can see on the surface of the barbed broaches, there will be a projection of barbs that helps in cutting or snagging the tissue, or even to remove paper points or cotton pellets that get stuck inside the root canal. So rasps are the similar instruments, but the basic differences between the rasps and the barbed broaches is about barbs, length of the barbs and the taper. The length of the barbs is small, short in rasps. Comparatively, broaches has uh, increased length of barbs, and also taper. The broach has the lesser taper of 0.07 to 0.10 mm, whereas rasp has more taper of 0.15 to 0.20 mm. And then here comes the smooth broaches. Smooth broaches are the broaches which are devoid of barbs on their cutting surface, also used as pathfinders. And next, hand operated instruments are K type of instruments that includes files and reamers. These are manufactured from Kerr Manufacturing Company with the ADA specification number of 28. So these files and reamers, they are similar in their function, that is cutting action, but they differ in several aspects, which is of more important for us in exam point of view. So let's look into that. um, the basic difference between the reamer and the file is the cross section. The cross section of the reamer is a triangle, whereas cross section of the file is square. Just to avoid the confusion, a small mnemonic here. File, it has got 4 letters, and the instrument has got 4 sides in cross section. So file has got 4, that means either square or rectangle in cross section. If we remember about this file cross section, then this will be remembered easily only. And this is the first difference between the reamer and the file. I repeat again, the first difference is the cross section, triangle for the reamer and the square for the file. And then cutting efficiency. Here, if we see the cross section, the angle of the reamer is the acute angle, whereas angle here is 90 degrees. So reamer has got the more cutting efficiency, whereas file has got the lesser cutting efficiency when compared to the reamer. And next difference lies in the cutting motion. Reamer is used in reaming motion, whereas file is used in filing motion. Reaming motion means uh, uh, during instrumentation, the reamer is placed inside the canal. It is used in um, placement, rotation, and retraction. So the cutting of so the cutting movement occurs during the retraction or removal of the instrument, whereas this file is used in linear motion. That means either in push or pull motion with no rotating motion. So I hope I'm clear about it. The basic motions, cutting motions. Reamer is used in push, rotate, and reciprocate, removal, whereas file is used in push and pull motion. And next difference is about flexibility. Reamers are more flexible compared to the files, and cross section, which we have already discussed. And when we take a 1 mm length of reamer and 1 mm length of file, the number of flutes in reamer will be less when compared to file, which has many number of flutes per 1 mm. That will be around 1.5 to 2 mm. Just make a note of it. um, to simplify it, we can tell it as in reamer, flutes are loosely arranged, whereas in files, flutes are tightly arranged. So because of the loose arrangement of flutes in reamer, there will be a abundant space between the flutes that helps in removal of debris, that prevents the apical extrusion of debris beyond the foramen. But whereas in files, as there is less space between the flutes because of their closer arrangement, there will be more apical extrusion of debris for the files. These are all the basic differences between the reamers and the files. Moving forward, modified K type of instruments. Um, why instruments are modified? Just to overcome the drawbacks which are present in the original version, right? So here, K instruments, what is the original drawback of the original version of the K instruments? Less cutting efficiency due to its cross section. So they have been modified with the different cross section of rhomboid or diamond shaped, that has got two acute angles A alpha and two obtuse angles beta, which helps in increased flexibility and the cutting action of the files. And one more modification of K instruments is flex R file. Sorry, one more modification is flex R file. And these are made by removing sharp cutting edges from the instrument tip, so that tips become rounded and remain centered in the canal. That prevents the procedural errors such as ledges or canal transportations that frequently occurs with the original version of the K files. So we are done with the barbed broaches, smooth broaches, and K type of instruments, that includes files and reamers. And now here comes the H type of instruments, which has got the ADS specification number of 58. These instruments are made by cutting or grinding the spiral flutes into the shaft of a piece of stainless steel wire, and the cutting motion is in only one direction, either in only one direction, which is retraction or pull motion. And the cross section of the H file is, as we can see here, it is teardrop shaped cross section with a single helix, and it should not be used in rotational manner. So H file has also got its own modifications, and the first modification was given by Max Padden, which was marketed as Unifile. Um, so this Unifile has got double helix design when compared to the single helix design of the original version of H-type instruments. What is the advantage of this double helix design? So that this instrument will be less subjected to fracture because of this cross section, but eventually they are proven less efficient, so they are not marketed now. And one more modification is S file. This appears to be a variant of unifile because it also has got double helix configuration. It can be used in any motion such as filing or reaming, so it can be considered as hybrid design. In this presentation, I have included and explained detail about standardization, classification of instruments, standardization of instruments, and the basic design of the endodontic instruments, followed by details of the hand operated instruments. I hope I have cleared few concepts. Thank you.